In the previous lecture, we completed practice set 1. Now, we will see decimal representation of irrational numbers. Let us see first irrational numbers. If the decimal representation of a number is non-terminating and non-recurring, then that number is called an irrational number. Example: 0.10, and so on is an example of irrational numbers. Next example is root 2. Root 2 is equals to 1.414213 and so on. Here you can see no number or no digit is repeating, nor any group of number or group of digit is repeating. So such number is called as irrational number. This is non-terminating and non-recurring number. Similarly, you can see another example, that is root 5, root 6 and root 7, etc. are all irrational numbers. Now let us calculate the division of root 2 by division method, which you have already studied in your previous standard. Now the answer is coming, that is 1.4142 and so on. And second, the answer is 1.7320508007 and so on. So from first you can see that it is not terminating decimal representation. What is meant by non-terminating? Non-terminating means you will not get a remainder as 0. You will continue solving the sum, you will not get 0. So such numbers are said to be non-terminating decimal representation. And here you can see no number or no group of number is repeating. You will get different numbers again and again as you will go on solving. So these type of numbers are said to be irrational numbers. It is non-terminating and non-recurring type of decimal representation. Such numbers are called as irrational numbers. Root 2, root 3 are irrational numbers. Now let's see C upon D. Now what is C? C stands for circumference and D stands for diameter of a circle, which is equals to pi. You have already seen studied in the previous standard. The value of pi is equals to 3.14. Approximately it is equals to 22 upon 7, which is equals to 3.14. Let's calculate this. 22 upon 7. Now let's solve one activity. Draw 3 or 4 circles of different radii on a cardboard. Cut these circles. Then take a thread and measure the length of circumference and diameter of each of the circles. Note down the readings in the given table. This activity is in your textbook only, page number 23. Now cut the circumference by using scissor. Now take thread and make a round circumference of a circle, and now take that thread and calculate the circumference of first circle, which is equals to 44 centimeter. Now take the diameter. Using a compass, calculate the measure of diameter, which is equals to 14 centimeter in first circle. Now radius will be half of the diameter, that is equals to 7 centimeter. Similarly, we will calculate the second circle. Circumference is 50.3 centimeter. Diameter is 16 centimeter. And radius is 8 centimeter. Now let's measure third circle. The circumference of a third circle is 34.5 centimeter. The diameter of a circle is 11 centimeter and radius is 5.5 centimeter. Now let's complete the table which is given in your textbook. And diameter is 14 centimeter. Circumference is 44 centimeter. Now we will do division of circumference and diameter, that is 44 upon 14, which is equals to 22 upon 7, which is approximately equal to 3.14. Let's take second. Radius is 8. Your diameter is 16 centimeter. The circumference is 50.3 centimeter. Now by taking the ratio of circumference and diameter, we get 50.3 upon 16, which is approximately equals to 3.114. Similarly, you can solve the third one. We'll find that the answer is approximately equal to 3.136, which is again equal to 3.14 only. So here you can see all the ratios are coming approximately equals to 3.14. So we can call that C upon D is a constant and the value is 3.14. Constant, which is equals to pi and which is equals to 3.1, and so on. Now let's take activity number 2. To find the approximate value of pi, take the wire of length 11 centimeter, 22 centimeter and 33 centimeter each. Make a circle from the wire. Measure the diameter and complete the following table. Now here you can see we have taken strings. First is of 11 centimeter, second is of 22 centimeter and third is of 33 centimeter. Now we will fold the string into a circle. We will bend the string into a circle. See. And now we will measure its diameter, radius and circumference. again, as we have done in activity 1, we will take a paper and cut the circles using a scissor. Now first circle, we will find the diameter, which is equals to 3.5 centimeter. For the second circle, we will find again diameter, which is 7.1, and for the third circle, the diameter is 10.6 centimeter. Now let's find the circumference. What we will do? We will open the string and measure its length. First string was 11 centimeter, that is circumference of the circle will become 11 centimeter. Second, it is 22 centimeter, and third, it is 33 centimeter. Now let's complete the following table, which is given in your page 24. 22 centimeter, third is given 33 centimeter. Diameter, first is 3.5 centimeter, second is 7.1, and third is 10.6 centimeter. Now let's find the ratio between circumference and diameter. 11 upon 3.5 is approximately equal to 3.14. Second, 22 upon 7.1 is equals to 3.09859, which is again approximately equals to 3.14 only. Third, 33 upon 10.6 is also approximately equal to 3.11, 32075, and so on, which is again I can say 3.113 is equals to 3.14 only. Okay. So here you can see that the ratio of circumference upon diameter is equals to constant, which is equals to 3.142857, which is again an irrational number. Irrational number means it is never ending. We will not get remainder as a 0. So there is a pi, we can take value as a 22 upon 7, or pi is approximately equals to 3.14. The great Indian mathematician Aryabhatta in 499 CE has calculated the value of pi as 62832 upon 20,000 is equals to 3.1416. We have already studied that root 3 is an irrational number. Now let's see, 2 plus root 3 is a rational number. Let us assume 2 plus root 3 is not an irrational number. It does not belong to rational number. It means 2 plus root 3 is a rational number. Assumption that 2 plus root 3 belongs to a rational number and does not belongs to irrational number. If 2 plus root 3 belongs to rational number, then 2 plus root 3 is equals to p upon q. Therefore, root 3 is equals to p upon q minus 2. What I did, root 3 kept here, and I'll take this 2 on that side, so it will changes its sign, and there it will go and be negative 2, that is minus 2, that is p upon q minus 2. Root 3 is a irrational number and p upon q minus 2 is rational number. According to our assumption, they are equal, but they are not equal. That means our assumption is wrong. This contradiction arises because of our wrong assumption that 2 plus 3 is a rational number. Hence, we concluded that 2 plus 3 is an irrational number. Also, 2 plus 3 is an 2 root 3 is an irrational number. Note: the sum or product of two irrational numbers can be a rational number which can be verified. 2 plus root 5 plus bracket of minus root 5 is equals to 2. 4 root 3 upon root 3 is equals to 4. 3 plus root 2 minus root 2 is equals to 3. 2 root 5 into root 5 is equals to 2 into 5 is equals to 10. Root 3 into root 5 is equals to root 15. 2 root 3 minus root 3 is equals to root 3. Now we will see the properties of irrational numbers. First is, the sum of rational number and irrational number is always an irrational number. Let's take example 3 plus root 2. 3 is a rational number and root 2 is an irrational number, but their sum 3 plus root 2 is an irrational number. Second, the difference of rational number and irrational number is always an irrational number. Example 5 minus root 2. 5 is a rational number where root 2 is an irrational number, but their difference 5 minus root 2 is an irrational number. Third, the product of rational number and irrational number is always an irrational number. Example 6 into root 5 is equals to 6 root 5. Here 6 root 5 is an irrational number. Here 6 is a rational number and root 5 is an irrational number, but their product 6 root 5 is an irrational number. Fourth, the product of irrational number and the same irrational number is always a rational number. For example, root 5 into root 5 is equals to 5. Root 5 is an irrational number, but this number when multiplied with itself gives the product 5, which is a rational number. Root 12 into root 3 is equals to root 36 is equals to 6. Here you can see root 12 and root 3 are irrational number, but their product is coming rational. The product of two irrational numbers can be irrational. Root 5 root 2 is equals to root 10. Here both the numbers are irrational and their product is also irrational. Now let's see division of irrational numbers. Root 18 divided by root 2 is equals to, answer is coming root 9, which is equals to 3, and 3 is a rational number. But when I divide root 18 by root 9, the answer is coming root 6, which is an irrational number. The sum, differences, product or division of two irrational numbers can be either rational or irrational. Now let us learn about the order relation. A real number A is less than B if and only if The point representing A on the number line is to the left of the point B. A number A is less than B can be represented by using a number line. Now let us learn the properties of order relation. For A, B, C belongs to real number, first property of order relation is one and only one of the following relations hold good. If A is equals to B, A is less than B. Third is A is greater than B. Second is if A is less than B and B is less than C, then A is less than C. For example, if 5 is less than 7 and 7 is less than 9, then 5 is less than 9. Third, if A is less than B, then A plus C is greater than B plus C. For example, if 5 plus 5 is less than 6, then 5 plus 7 is also less than 6 plus 7. 4. Let A is less than B, then if C is greater than 0, then AC is less than BC. For example, if 5 is less than 6 and C is equals to 2, which is greater than 0, then 5 into 2 is less than 6 into 2. You can see 5 into 2 is 10 and 6 into 2 is 12. Therefore, 10 is less than 12. If C is less than 0, then AC is greater than BC. Example, now let's see square root of a negative number. Suppose root of minus 5 is equals to x. Then we will take square root on both the sides, and therefore what we will get is minus 5 is equals to x square. X square is equals to minus 5. Note, the square of any real number is positive. The square root of a negative real number is not a real number. Third, the square root of 0 is always 0.